Hey there, it's Dina from IDon'tGetItTutoring.com. In this video, I'm going to go over how to find the average rate of change. Let's get started. So, average rate of change is super useful, especially in equations, but it's also useful in everyday life. Have you heard the expression beats per minute? Or miles per hour? Well, those are average rates of change. So basically, if you want to find the beats per minute or the miles per hour, there's this little magical formula that can give you that rate. So without further ado, here is the formula. y2 minus y1 over x2 minus x1. Hello, what does that mean? This doesn't make any sense. What's y1, y2? It's not super complicated. It's really easy, but you need to have multiple values in order to calculate this. You need at least 2 points. Also, ROC just means rate of change. So let's say you have a list of values. Let's say I don't know, we have x be the amount of miles driven. No, sorry, y would be the amount of miles driven and x is the amount of time, so the minutes. So let's say we have 0, 1, 2, 3, 4, 5 minutes. And well, it is over hours, so let's put x as hours and y is miles. Okay, let's say we have 0 miles at 0 minutes. Makes sense. When the car isn't driving, doesn't move. Okay, so let's say we have a set of values just like this. Let's say you sat there and you measured the speed of your car every hour. Not the speed, I apologize. The amount of distance your car drove every hour. Like you're driving and at hour 1, you took a look and recorded how far you had driven. I wouldn't advise you to do that as you were driving. Hopefully you were a passenger and you did that. So anyway, we want to figure out how many miles this car traveled per hour. Now, you would take these pairs, right? So let's say we had 120. You could turn these into pairs, x and y pairs. To make it a little easier, or maybe it doesn't make it easier at all, but I find it might help a little bit. So you take these coordinate pairs, right? You could pick any two, literally any two. You just need 2 pairs in order to be able to use this equation. So you could pick this one and this one. You could put this one and this one, this one and this one. They don't have to be next to each other. Doesn't really matter. However, it helps in more cases than not to use the starting point and the ending point. I know sometimes graphically, if you're using a linear equation, I cannot stress this enough, linear, straight line, which increases by a constant amount each time, that is fine if you do any 2 points on that line. That is okay. However, if the line is a little curved, or it's a parabola, or anything else, if you could see that the y's don't go up by a constant amount each time, x goes up by 1, not 2, not 3, not 5, 1, then yeah, you could pick any 2 points. But let's say x didn't go up by 1s as nicely as this, and x went up in like weird increments, like 2, 8, 19, 21, 22. That way, it's not increasing by the same amount each time. It's increasing, if we had 0 to 1, that would be 10. 10 to 2 would be 20. 2 to 3 would be, I don't even know how much, a lesser amount. Certainly wouldn't be 10, because 2 to 8 is 6. So you would have to do 40 minus 20, which is 20. 20 divided by 6. And then that's how much it would go up for this interval, and so on. Super complicated. So a good rule of thumb is just to start with the beginning value and the end value, and then to calculate it from there. So you're going to take the very first value that you see, and then the very last value that you're given, and then that way calculate it. So in this case, we are going to use this point and this point. Let me fix the x values now. So we're using this one and this one. Oh, no, actually, I forgot the point. 0, 0. So these are the points we are working with. Oops. There we go. Okay, so we have 2 points, which are, okay, this is not cooperating with me. I'll just rewrite them. 0, 0, and 5, 100. Okay, so we have our x's. Our latest x would be 5, and that is x2, and x1 would be the very first one, 0. And then in terms of y's, y2 would be this one, and y1 would be this one. A lot of people confuse them, but make sure you know the difference and don't mix it up. So we are going to do y2, 100, minus y1, which is 0. That's going to be over x2, which is 5. And that's going to be minus x1, 0. So 100 minus 0 is 0. Not 0. 100 minus 0 is 100, and 5 minus 0 is 5. 100 divided by 5 is 20. There you go. That is the rate of change in this table. And as you could tell, since it's going up a nice amount each time, like I said, this would be considered a linear equation. Some, if you want to get into patterns, this could be technically an arithmetic sequence. We have videos about that on our website if you do not know what that is. Let's try one more example with the same equation. Now I'm going to do one where x isn't as consistent. Actually, I don't want to use such big numbers. Okay, What is the average rate of change of this table? Now, same thing. What are the two pairs we're gonna use? Latest and earliest. Write them out. 3, 0 and 15, 10. We're going to take y2, and this is going to be our y1, and this is going to be our x2, and this is going to be our x1. And then we plug it in. So y2 minus y1 over x2 minus x1. Subtract 10 minus 0 is 10, 15 minus 3 is 12, 10 over 12 could be simplified into 5, 6. That's the average rate of change. There you go. Average rate of change, by the way, doesn't really have any units. It's just 5 over 6. And yeah, that concludes our video on average rate of change. Thank you so much for watching. I hope you found this helpful. Bye.